If you missed class today, this is probably the most important part of what we did as product of our lesson today. And what I did is I took a simple formula which we have used before. This is the thermite reaction, and I showed how to get all the possible mole ratios. And basically to do that, what we did is we took and drew arrows to everybody, connecting everybody to everybody. And so watch as I do this. I do it in a very, very organized fashion, which allows me to rule out things as I go, which is pretty neat. What I have just done is I have connected the first substance here, aluminum oxide, to iron, and then to iron oxide, actually iron 3 oxide is the way we would name it, and then to aluminum. So now you can see aluminum oxide hooked to iron, and then it's hooked to iron 3 oxide, and then it's hooked to aluminum. Next, we're going to connect everything to everything by going down to the bottom side for our arrows, and watch how these go. That is a duplicate, isn't it? So we don't want to start there. We want to start with the second guy. As I go from left to right, I'm eliminating things to the left. For instance, right here, when I started with the iron, I didn't need to worry about the aluminum oxide because the aluminum oxide is already hooked to everything. But iron isn't hooked to everything. He was hooked only to aluminum oxide. So now I go forward and I hook him to everything to his right. And that's why we have these 2 black arrows. And the last arrow that we need for this reaction that last arrow now connects iron oxide, iron 3 oxide here, to the aluminum. And now everything is connected to everything. Aluminum to iron 3 oxide, to aluminum. Iron hooked to iron 3 oxide and aluminum. And then you see as I go to this guy to hook him to someone else, there's only one left. I don't need to worry about the guys to my left. I just continue looking forward. And now I have the opportunity to hook him to the aluminum, and of course the arrows always go 2 ways, so I'm hooking them in both directions. And so I count my arrows, 1, 2, 3, 4, 5, 6. I wind up with a total of 6 arrows, and why did I write 6 times 2? Because 6 times 2 gives me my total ratios, which is 12. And now with my total ratios there, I'm ready to go on and make sure that I get them all. And so I do that in an organized fashion as well. And before we do that, I want to just leave this little tag here so that I remember what it is that I did here. So let's start with the very first arrow, this guy right here. And for that, we're going to have 1 mole of aluminum. 1 comes from the coefficient of aluminum oxide. I meant to say aluminum oxide. 1 mole of aluminum oxide to 2 moles of iron. And then we move on. Second arrow. Here, let's see if I can get this to pick up. There we go. And here's my iron. So let's get that same ratio now in reverse. So now I have 2 moles of iron to 1 mole of aluminum oxide. Then I'm going to go to this arrow. And for that arrow, I have aluminum oxide to 1 mole of aluminum oxide to 1 mole of iron 3 oxide, this stuff. Now let's go to the third arrow on top side, and that is going to be the aluminum oxide and the iron. Whoops, aluminum oxide and the iron. Sorry, that guy is the second one for this arrow. Now let's do this arrow, and that's going to be the aluminum oxide, 1 mole, to 2 moles of aluminum. And then when we flip that guy, we've got our first 6 mole ratios all generated from the red arrows. Now let's go down and watch how we do this guy. He is 2 irons to 1 iron oxide. And that is our first black arrow. The second black arrow, whoops, we got to flip it first. Let's flip that first one. Okay, you see how that got flipped? Now let's move on, and we've got 2 moles of iron. Okay, 2 moles of iron right here that we're hooking to the aluminum. And, of course, we have to turn that guy upside down. And then our last arrow, the green arrow, which hooked the iron 3 oxide to the aluminum, and then the reverse as well. And there's our 12 total ratios. And that's how we do it. Another screen that I used today was how to calculate the possible mole ratios in any balanced equations. And for this, all we have to do, and let's clear the screen up a little bit for you. And now let's focus on just what I've said here at the top. How to calculate possible mole ratios in balanced equations. Well, here it is, right here. And that is the total reactants and products together times the total reactants and products together minus 1. And we multiply those two by each other. And for the kind of reaction that we were just talking about, I had 1, 2, 3, 4 total reactants and products. So what are our numbers going to be? We have, and let's kind of dispense with some. Yeah, I just covered this up because we'll look at that later. And let's go back now and look at total reactants and products. Total reactants and products in the 4 reactant product type combinations. We have 4, which is 1, 2, 3, 4 total reactants and products, times 4 reactants and products minus 1, which is 3. So 3 times 4 is 12, and you see that that matches perfectly with what we did back here. Okay? Now, hiding under the little black box right now are these numbers. This would be if we had a total of 5 reactants and products. So we have 5 reactants and products. 5 subtract 1 is 4. So if we add 1 more reactant or product, we're going to wind up with 20 mole ratios. It gets to be a lot, doesn't it? Okay, now let's focus on the last thing. And that is, how do we figure the mole ratios that are possible within a molecule? And you can see I used aluminum carbonate here. And aluminum carbonate, if we look at the ions that make it up, it's going to be aluminum and carbonate. So because of the coefficients here, not the coefficients, I'm sorry, the charges of those two molecules, or atom and molecule, we wind up doing a crisscross to give aluminum a 2 subscript, which 2 times 3 plus is 6 positive charges, and 3 carbonates, with a 2 minus charge gives us 6 negative. 6 minus 6 is 0, which is what you need in a balanced molecule. So here we are with our aluminum carbonate, and now we just are going to check out the total ratios that are possible. So I'm just going to use the arrows here, and the arrows connect aluminum to carbon and aluminum to oxygen. We also can connect carbon to oxygen, and each arrow gives us 2 ratios for a total of how many? Yes, 6. So 3 over here, 3 times 3 minus 1. Oh, that looks just like the last deal we worked with, isn't it? And so that's going to give us the same kind of a deal that we had here. Okay? Reactants and products in this case will now be the total number of atoms. So total number of atoms times the total number of atoms minus 1 gives us a total of 6. And that's how it works for molecules. I hope you find this useful.